Hello and welcome back to another video. Today we're going to be exploring this Ecosmart 9.5 watt warm light bulb. This has an SKU 10013703884. Model is B7819A 60WESD14. It is 9.5 watts, 800 lumens, 120 volts, 2700K, 101 milliamps, 60 hertz, made in China, and day code is 0421, which means the 4th week of 2021. It is UL listed under standard 4 EU2, and the UL number is E345327. So this one's flickering intermittently, so we're going to open it up and see if there's anything actually damaged inside. This was used in an enclosed luminary, and that's where it was flickering. So I think it was partially due to heat, but we're just gonna open it up and see if anything actually failed inside. Oh, this actually says it is suitable for use at totally enclosed luminaries. So this should have been fine. I don't know why it's flickering, but we're gonna take a look at it. Alright, we got it opened up, and I guess on this board it looks like pretty much everything's on this board. So you have the two wires coming through here on the two connection boards. You have your 8 diodes, bridge rectifier over here, and I'm assuming this is a switching chip. It is marked CWHCW1. A few resistors, another resistor here. Other than that, there's not really much that's noteworthy, so let's take a look at all the other stuff in here. I'm assuming one of these is a capacitor, but I can't... Oh, the capacitor is right here, so we're going to take a look at that capacitor. And other than that, this should be pretty simple. Alright, let's dig a little deeper. So, on the line-in AC side, we had our fusible resistor. Unfortunately, I don't think I'll be able to get a good reading from that because I kind of damaged it, but... So we have that. On the other side here is just the other line-in wire for neutral. The fusible resistor is always going to be wired to live. And you can see actually this is an aluminum PCB, so that's good for heat sinking. And we have our capacitor here. Aishi. Not great, but okay. CD11GES, 103 degrees C. And it's just in there with a connector, so I think I'm going to try and sketch out a schematic, so you'll get to see my amazing schematic drawing skills. And here we have my first schematic of the channel. And if you were wondering if I wrote it this neatly first, I did not. This was the first draft of the schematic, but you can make it a lot neater when you already know what you need to draw. So I'll just guide you through it here, step by step. First, you start with the mains voltage. In my country, 120 volts AC, 60 hertz. This light bulb will not work on 220, 230, 240 volts. At the very least, because this capacitor is only rated for 160. So if you plug it into 240 volts, you'll probably hear a pop or a bang or something like that. But anyway, you start with 120 volts AC, 60 hertz. The line voltage goes through a fusible resistor. So it's both a resistor and a fuse, and that just helps with protection. And then you also have the neutral, and they both go into this bridge rectifier labeled BD1 on the board. Bridge rectifier. Right here, this 4-pin device. And then you see the neutral part here. This side is positive, and then the other side is negative. Positive goes through a diode and a 200 ohm resistor into this chip. HCW1, I believe. So that goes into pin 3 of this chip. The negative voltage goes through two resistors, a 5.6 ohm resistor and a 6.2 ohm resistor, which are in parallel, and that goes into pin 6 of the chip. So across pins 5 and 4 of this chip, you have C1, which is a 33 microfarad 160 volt capacitor. And across that capacitor, you have all of your LEDs. So you get about 17 volts per LED, but these aren't regular LEDs. These are LED chips. So these have multiple LEDs in them. But basically, it's a very efficient way here to basically tack the capacitors across mains voltage, but in DC, and then you don't need any extra regulation circuitry. So you have your 9 LEDs here, and they're across this capacitor. And that is the circuit. I hope you enjoyed this video. I hope you enjoyed the teardown of the bulb. And the circuit diagram, the schematic. So hopefully that was enjoyable. If you like this video, please give it a like and give my channel a follow. And I will see you at some time in the future.